And the other type of exponential functions we're going to come across is referred to as an exponential decay. Okay, so if you think about something decaying, right, when we bury something in the ground or an animal or something, when it decays, right, it is shrinking. It's getting smaller and smaller and smaller and smaller as time kind of passes through. So when we hear about exponential decay, the number should be decreasing. Right? So decay is just kind of a fancier word referring to this guy decreasing. I just showed you 3 examples of everything increasing with exponential growth, and you should notice that your b values, okay, your b values was everything larger than 1. Okay, it wasn't necessarily your whole numbers, right? We did an example of a multiplier being 3 over 2 or, the 1.5 thing. So it just has to be bigger than the number 1. When we're talking about an exponential decay, okay, so if everything bigger than 1 is a growth going the other way, b has to be smaller than 1. Okay, so when we're dealing with numbers smaller than 1, okay, we're dealing with an exponential decay. But it also has to be bigger than 0. So the numbers that are bigger than 0 are positive numbers. So we are not ever going to come across an exponential decay where the multiplier is going to be a negative. Okay, in order for the numbers to be decreasing, okay, it's got to be in between 0 and 1. So when you think about what numbers, how many numbers are there in between 0 and 1, there are no whole numbers, right? Whole numbers go from 0 to 1. We're talking about everything in between that. So these are going to be your decimals and fractions, right? So think about, if something has to get smaller, right? So if you think about eating a piece of pizza, in order to get it to be not whole again, we eat half of it. We eat half of it again. We eat another slice. So in order to get for it to be smaller, right, it's got to be a fraction. Think about maybe cutting something in half or thirds or what have you. Okay. So again, the multiplier has to be less than 1, but it also has to be greater than 0. It's got to be a positive value there. Okay, so let's write some equations here. Again, remember we are going after 2 values. We need A and we need B. Again, if A is given to you, it should be super easy to spot. In this particular case, it is, right? X at 0. We should be able to see that we're at 50. So my A value here, when X was 0, we're at 50. Now we got to look for the multiplier, right? How are we getting from one number to the next? Again, maybe we can't eyeball it right away. We have that mathematical approach, right? So again, B, the second number divided by the first number So I'm going to go here to here. If I want to know what multiplies to get from 100 to 50, I'm going to take 50 over 100. So remember, this is referred to as a multiplier. This is not a divider, okay? You're not finding what divides you get from one number to the next. What multiplies, okay? So again, referring back to your calculator, you're going to need a lot of calculator work with this stuff. 50 over 100. And what's really nice is your calculator does simplify for you. We got that number 0.5. Again, this is a nice decimal for us. It terminates, but you really should use to turn this into a fraction, right? Math enter turns that into a 1/2. So my B value, all right, this is going to simplify out to be a 1/2. And notice, right, as my X values got larger, my my Y values, they are getting smaller. 100 to 50 to 25, right? This is a decay. Notice what my multiplier is, right? It's 1/2. 1/2 is directly in the middle of 0 and 1. Okay, so let's put our pieces together here. Y equals the initial value of 50. Again, I'm going to use my parentheses raised to my exponential x, and that multiplier we found to be 1/2. Something, kind of taking this a step further to see if it's exponential everywhere. We could have done, 25 divided by 50. 25 divided by 50, and it should give us that same 0.5 or 1/2. One thing I didn't stress before, make sure you're picking consecutive numbers, right? Notice how I did, 50 over 100 or 25 over 50. This will not work if you do 25 over 100. So you can't just pick any two numbers, okay? It's got to be consecutive numbers there, okay? That kind of takes on a whole new spin and something that we're not going to talk about this year. If we, do have, jumps in between, or, we've got to divide by bigger numbers there. So make sure you are kind of picking consecutive numbers. Okay, so again, I got two more examples for you here. Again, notice the table is written horizontally. But notice how the x values are getting larger, right? 0, 1, 2. What are your y values doing? Right? They're getting smaller, okay? So that should be a dead giveaway. This is exponential decay. You are looking for fraction numbers. You are looking for a multiplier in between 0 and 1, okay? So let's lay it out. Again, my a value, okay, should be easy to see that x is 0. My a is 90. Okay, now we got to find that b value. Okay, what am I multiplying by to get from one number to the next? Again, pick consecutive numbers. Just simple enough. Pick the first two that you see. So b is equal to 30 over 90. Okay, remember the second number you see divided by the first. So 30 over 90. Okay, so this is a bad decimal. This will not stop. Okay, you cannot write this in your calculator. Okay, whatever number you stop, there's going to be an infinite amount of more threes that you did not write. So you have to turn this into a fraction. If you don't, you're not going to get to where you need to go. Okay, so there's bad decimals, these non-terminating guys, you have to turn them into a fraction. So 30 over 90, my fraction turns into be a 1/3. And again, you could have done the 10 over 30 and got the same result, but repetition does help you here. So my b value is 1/3. Again, being able to put the pieces together, y is equal to, the initial goes first. I mean, simple enough. It's called your starting value. It's called your initial value. So kind of does make sense that we write that first. And then my exponential x there, and my multiplier is going to go in parentheses. We found that out to be a 1/3. Okay, so always, one thing I said earlier, double check your work. Being able to substitute these coordinate points or values of x and y into your equation and seeing if it does work out there for you. Okay, so one last example. Okay, so you should observe from this table, I didn't give you when x is 0. Okay, so don't just write the first number you see. We need that x at 0 term. Okay. So it looks like we've got to work a little bit harder for this one to go find it. So again, I'm going to kind of set us up here. Remember, we need the a value and we need the b value. Okay, so since a wasn't given, we've got to go find b. Okay, so how or what is our multiplier to get from 30 to 12? So, I don't think I could even guess the correct answer here. So, you've got to be able to understand, in order to find a multiplier, the opposite means to divide. So I'm going to divide 12 over 30. Okay, and this is order to find b. So again, your calculator, 12 over 30, and it tells me 0.4. So this decimal is nice. It stops there. There's no other numbers after 0.4. But again, you really should get used to using that fraction. I'm going to use 2/5. So 12 over 30 simplifies to be 2/5. Just to make sure that, we're all in the same boat here, let's try to do that other number. So the 4.8 over 12, right? So the third number divided by the second number, and it should give us that same 0.4, and it does. Okay, so this is an exponential function. It is using the same multiplier throughout. Okay, so that's one piece that we really need. So I'm going to go ahead and write that down. My b value is 2/5. Now, we've got to find the initial. We've got to go back to term 0, right? So it's a multiplier going this way, right? So 30 times that 2/5 takes me this way. Going back the other way, we're dividing, okay? So we've got to do the opposite coming back the other way. So in order to come backwards, I have that 30, and I'm going to divide it by the 2/5. Or you could have divided it by the 0.4. However way you want to do it, like I said, this decimal is nice to you, so you can use the decimal. But regardless, notice how the number got bigger. So when we came back up, this turned into a 75. So maybe one issue you may run into, understanding that this is a multiplier, you may do this, 30 times that 0.4 that you saw, right? But the number's getting smaller. We already have that 12, okay? So we've got to go the other way, right? We've got to divide coming back the other way. So, so stuff like that, if you're truly understanding what's going on, being able to catch your mistake there, when coming back this way, the number should have been bigger. So really pay attention to that. So 75 there is my A value, right, when x is 0. So putting my pieces together, y is equal to my initial, right, when x is 0, parentheses with my exponential x, my multiplier being 2/5. Okay, so that's 6 examples there. Hopefully that kind of helps out. And I do have an assignment up ready for you in Delta Math there.